So we're getting ready for our first test. Now, the review for this, I'm not going to do problems. I'm going to tell you what to study, and then you go find the problems. And trust me, you'll be fine if you listen to what I'm saying very carefully. Now, the first thing is I'm going to say call it chapter 3, but if your book isn't chapter 3, it doesn't matter. Just if it's, this would be talking about the substitution technique, elimination technique, solving systems using Gauss-Jordan elimination. The main idea here, we weren't learning substitution and elimination. Those were review. The main thing you were supposed to be learning was Gauss-Jordan. So therefore, you can guarantee on the test, I'm going to have you do one problem by hand, where it's going to say, solve this problem using Gauss-Jordan technique, Gauss-Jordan elimination technique by hand. You will be required to show me the work. You'll be required to show me the row operators. You're going to be required to show me the whole process, start to finish. You can, of course, check your answer with a calculator, but it must be done by hand. That being said, how many of those problems do I need to see you do to verify you know how to do the process? Yeah, just one, right? After you show me this process once, we're good. So after you do your one problem of Gauss-Jordan by hand, the rest of what you'd be getting out of the section is just word problems. Word problems, word problems. Let me kind of emphasize this. You're going to have something on this test. It's the concept of a word problem, right? And there's going to be many of them. Now, that being said, you don't have to do any of those by hand, right? If the directions don't explicitly say do the problem by hand, don't do it. Instead, just what I want you to do is show me your setup matrix, whatever it may be, and then you can do RREF and say that gave me 100, whatever it was, right? And you can fill in your answer. So the key to this is you just show me the matrix you created, you show me the reduced echelon form. Oh, and of course, write the equations. So whatever your original equations were, and make sure you define for me the variables, what x means, what y means. So that way, if you made a mistake or if I need to look at your work carefully, I'm not trying to guess at what these variables mean, because I'll give you a hint. I'm not going to spend a whole bunch of time guessing. So make it as clear as possible, make it as neat as possible, but you don't have to show me the work other than just what the calculator took in, what the calculator spit out. That's it. That's chapter 3. So I hope you know what to go practice. And if it wasn't clear, let me do this one more time. If let me kind of emphasize. I hope you know what to go practice. It's kind of important that you need to practice word problems. Lots and lots and lots and lots of word problems. Go do every word problem you can find. Okay. Next, chapter 4, main ideas. Solving systems using inverse matrices. Okay. That was really the only new thing. We had a little bit intro of just how we work with matrices. But no, the big idea was solving using inverse matrices. That's AX equals B, right? And how do we solve a matrix when it's in this form? Well, we multiply by A inverse on both sides. So that gives us X equals A inverse times B. Now, the main difference between chapter 3 problems and chapter 4 problems is when would you use this technique? When do we need this technique, right? We have to use this technique. I hope you kind of figured out at this point when you're doing it, that if I gave you this problem, for example, 3x plus 4y equals 4 and 7x minus 2y equals 3, there is no reason you would have to use ax equals b to solve this problem, right? Might as well just use reduced echelon form. It's quicker in the calculator, it's easier to do. But instead, if it was the same equations where one of them equaled a number that was unknown, we'll call it v, and the other equation equaled w, now I can't do reduced echelon form in the calculator. Please don't be that student who powers through and does it by hand. No. The directions will specifically say solve using inverse matrices. So therefore, you're going to take your inverse matrix, you're going to take your matrix A, use the calculator. You do not have to do that by hand. The calculator, use it to get your A to your A inverse, right? And then multiply it by your B matrix, multiply it by your output matrix of V and W. Yes, you're going to have to multiply that by hand, but it shouldn't be a big deal. So go back and review. How do you do that? Find the problems in the homework where they specifically had your answers, your equations set to unknowns, and make sure you can do all that multiplication by hand. That was the big idea in chapter 4. How many of those problems do I need to see you do to verify you know what you're doing? Yeah, like one, right? You do it once. I kind of got the idea. So not going to be a ton of those, but I promise you there will be at least one. All right, then on to chapter 5. What was the main ideas? Not the graphing and shading and testing corner points. That was supposed to be review. It's standard simplex, general simplex, and dual method. So the key to this is being able to recognize what is a standard problem, what is a general problem, when am I using each technique? Because if I just start you with a matrix and say here's X, here's Y, here's Z, W, whatever, and it is just filled in something like this. Well, whatever, with filled in with numbers. I'll just leave it at that. It's just filled in already, middle of the problem. You need to be able to look at that matrix and say, am I doing standard matrix techniques? Am I doing general matrix techniques? And I will tell you, I can't say, or is it dual? You have to know. Someone would have to tell you, is this a dual problem? But if I tell you it's a standard simplex problem and you're in the middle of the problem and I want you to do the next row operator, you need to be able to look at it and understand, is it a standard problem or is it a general problem? Am I in my solution region or am I not in my solution region? So if that's unclear to you, please, try to clear that up, or you can ask me for an individual video and I can help you out with that. But you have to be able to do that step. Now, I will not ask you to do a problem from start to finish on standard simplex. I will instead say, here's a problem, box the pivot wherever the pivot may be, and write your row operators, row 1 minus row 2 to make a new row, whatever. Okay. But I will not ask you to do the calculations. I will just ask you to identify the pivot, tell me what your row operators will be, and be done. So that means you will have lots of problems on this because I need to verify, do you know how to find your pivots for standard? Do you know how to find your pivots for general? Do you know how to do your setup or your pivots for dual? And do you know how to read your answers? So some of them, it'll just say, here's the finished matrix filled in with all numbers and with whatever, and I'll say, just read your answers. Tell me what the answer would be. That's it. And then, of course, word problems, word problems, word problems. So here is the word problem. Here is the solution matrix. Tell me what it means. So I hope that makes sense. If that is unclear, please ask, because I don't want you preparing for Chapter 5 where you think you're going to need to do a whole bunch of adding and subtracting, or you're going to need to work problems all the way start to finish. No, that's not what we're doing. And you're not allowed to use any of those helper websites during the test because you don't need them. You're not going to be solving problems start to finish, so you don't need those websites. All right, I hope this helps, and study, study, study.